Assalamualaikum and a very good morning to the panels. My name is Syed Abdul Rahim bin Dawi. My student ID is 2018-265-136. I'll be presenting my title, Stochastic Study on Dynamics Characteristics of Complex Jointed Structure. Project Summary. To model a finite element and to analyze the complex structure is cumbersome due to the consideration of material properties in determining the dynamic behavior of bolted jointed structure. Thus, this project aims to investigate the stochastic structural response of the numerical model. Finite element analysis of bolted jointed structure will be constructed using MSc Patran-Nasran and Monte Carlo simulation, whereby the experimental model analysis will be conducted using hammer, accelerometer, and LMS excitation on a free boundary condition. The outcome of both experimental and simulations will be compared to evaluate the stochastic structural response. Next, introduction. Finite element analysis has become the alternative to predict the behavior of the complex jointed structure. It is impossible to produce a good modeling that imitates the response such as experimental result. This happens due to the numerous uncertainties exist in the modeling of the structure such as material properties, structural geometry, and boundary conditions. CATIA is used to design a 3D model according to the precise dimensions of the structure and then imported to MSc Natran-Pasran to proceed with simulations. The dynamic behavior measured are natural frequencies and mode shapes of the complex jointed structure. The dynamic behavior of the structure depends on the modulus of elasticity, Poisson's ratio, and density that resulted in different natural frequencies and mode shapes. The result is then compared with experimental model analysis for validation. Stochastic reconciliation method using Monte Carlo simulation is used to improve the accuracy of the dynamic behavior of complex jointed structure. Monte Carlo simulation is actually a method that speculates the probability distribution of numerous outcomes when deals with stochastic random variables. The Monte Carlo simulation is used in the project because it is simple and widely used in the industry and proven with its results. Next, literature review. Firstly, the complex structure. Complex structure can be found in numerous sectors of industries. Common structural joints are bolted, welded, and riveted joints. Complexity of the structure always becoming a debatable issue in the structural analysis and design due to the configuration, loading pattern, and selection of the structural configuration. Consideration of the function to be used in the structure also determine whether the design and analysis of the structure is complex or not. The example of bolted jointed structure in the complex structure are superstructures of long span, screw, and curved bridge, and also the structure of offshore oil and gas production. Figure on my right here shows three different types of dimensions with the actual models changing into the finite element expression in the finite element analysis, which require the length, area, and volume. Next, Monte Carlo simulation. Stochastic finite element method is an updated version of finite element method that assimilates random parameters in the numerical method, such as geometry, external forces, and material properties. Monte Carlo simulation is a method that speculates the probability distribution of numerous outcomes when deals with stochastic random variables. It is a statistical method that solves mathematical problems through random sampling. Figure below shows the process of obtaining a better results in the numerical simulation or numerical analysis. Finite element analysis. Finite element analysis is the simulating process to determine the dynamic behavior such as the natural frequency, damping ratio, and mode shape of the bolted joint so that it can be assessed during finite element method. Mathematical modeling is used in the analysis of the finite element model to quantify the dynamic behavior of bolted joint structure. And appropriate finite element modeling can be done efficiently by predicting the dynamic behavior of bolted jointed structure. Finite element analysis consists of three components which are pre-processing, solution, and post-processing. Mesh size and order is crucial to create balance between accuracy result and run times. There are different types of mesh shape such as quadrilateral, triangular, prism, and many more. In pre-processing method, the software used is MSc Patran, where the main focus are to assign the type of element, use of appropriate mesh element, inserting material properties, and apply the boundary conditions in the form of load on the structure. The solution or solver phase, which require the use of MSc Nastran, will include solving the pre-processing numerically by using the equations into matrix form, namely direct and iterative solver. The direct solver, which consists of LU decomposition method and Gauss elimination method. On the figure on my right here shows the different types of meshing size, which resulted in different natural frequency or known as eigenvalue. The difference in natural frequency or eigenvalue will result in the different mode shape representation. Experimental modal analysis. Experimental modal analysis is the adaptation of the physical structure to determine the modal parameters or vibration characteristic. It involves a mechanical exciting of a structure under impulse or force that will measure the vibratory response. Natural frequency, mode shape, and damping ratio are the characteristics that can be identified using either impact hammer or shaker. Leuven measuring system is the data acquisition system which gain information from the modal parameters of the experimental work. Frequency response function is a measurement of displacement, velocity, or acceleration response of a structure at an output degree of freedom per unit excitation force of an input degree of freedom. Figure on my right here shows the past research where it uses experimental model analysis to result in the frequency of the undamaged and damaged structure. Lastly, element connector. Element connectors are used to connect two or more plates or structure together. Different element connectors proposed on the bolted model, namely C-bar, C-beam, C-bush, and C-lass. C-beam is a beam connector that supports bending, extension, mainly into perpendicular planes, and the associated shear. C-bar is the simplified version of C-beam and used when the cross-section of the structure and the properties is constant and symmetrical. C-bush is a structural scalar element connecting two non-grid points or two coincident grid points or one grid point. RBE2 and RBE3 is placed on the bolt's head and nut, which doesn't require any properties inserted on them. RBE2 is a one-dimensional element of a multi-point constraint, where it is made up of a dependent and arbitrary number of independent nodes. RBE3 uses a set of nodes to calculate how one or more nodes should move. Figure on my right here shows the picture of a past research where the bolt representation is for C-beam and C-bush, where RBE3 on the bolt's head or nut. C-beam and C-bush used in the study because it has better accuracy and lower error. Problem statement. There are some constraints in the process of creating the analysis, such as the problem in constructing the finite element model, and the rising of uncertainties in the modeling of complex structure, such as material properties, boundary condition, and structural geometry. There are the unpredictability considered, such as the lack of data unprocessed, the accuracy of mathematical model validity, and discretization error of the mesh density and size. The stochastic reconciliation method using Monte Carlo simulation is used to improve the accuracy of the dynamic characteristics of complex jointed structure. Objective. The first objective is to investigate the stochastic structural response of the numerical model. Secondly, to evaluate the accuracy of the stochastic structural response of the numerical model in light of the experimental data. Scope and limitation of project. Software used to construct the finite element model is CATIA. Material of the structure for plate is AISI 1018 mild steel with the standard elastic modulus of 210 GPa, Poisson's ratio of 0.30, and density of 7,900 kg per meter cube. While the material for bolt is AISI 1065 carbon steel with the standard elastic modulus of 200 GPa, Poisson's ratio of 0.30, and density of 7,850 kg per meter cube. Analyzing the dynamic behavior of the structure is using 5 mm meshing size in MSc Patran. The reason 5 mm meshing size is used in the study because the past researchers seek to find between 1 mm to 10 mm meshing size, where he finds out that between 3 mm to 5 mm produce better CPU time, CPU processing time, and lower memory usage, while maintaining the error is almost the same with 1 mm meshing size. Then, the normal mode solution is performed using MSc Nastran, with the interested behavior are natural frequencies and mode shapes. Frequency ranging between 0 to 1000 Hz and the first 10 modes of the complex structure is analyzed. Element connectors used for bolt's head and body are C-bar and RBE2. C-bar used in the study because number 1, it can define torsional, bending, and shear stiffness, and number 2, because it has the same cross-sectional area and material properties on the 4 bolts together. Thus, the predicted dynamic behavior will be compared with experimental data. The result of both experimental model analysis and finite element analysis are analyzed using model assurance criterion to predict the most accurate mode shape representation. Model assurance criterion is used to determine the result of the natural frequency and mode shape to determine the error and also the accuracy. Next, methodology. The process flowchart here shows the start to end process, where it determines and finalizes the complex structure, then move to experimental model analysis where the experiment is set up, and run the experiment where LMS acquired the natural frequency and mode shape. On the finite element analysis, I constructed the model, then run the finite element analysis using MSE Patran and Nasran, then use stochastic simulation, which is Monte Carlo simulation, to improve the accuracy results, and the generated and natural frequency and mode shape will be compared to the experimental model result to validate it. This is the explanation of the process chart. CATIA is used to construct the finite element model. Material of the structure for plate and bolt is added on MSE Patran together with element connector used in the study. Then MSE Patran will analyze the dynamic behavior of the structure using selected mesh size with the normal mode solution is performed on MSE Nasran solver. Results generated from normal mode analysis are natural frequency and mode shape. Monte Carlo simulation improved the finite element analysis result by applying the process as follows. Number 1. Determine the random properties and geometry of variables. Number 2. Distinguish the density function and interconnection parameters of the random variables. Number 3. Applying a random field generator to create a random set of field. Number 4. Use finite element modeling solver to calculate each realization. Number 5. Information gain need to be analyzed. And lastly, verify the results. Experimental model analysis is performed on bolted structure using free boundary condition assisted by postgraduate student. It uses an impact hammer and roving accelerometers in determining the natural frequency and mode shape. Given measuring system, acquire the natural frequency and mode shape data from the model parameters of experimental work. Lastly, the data acquired from experimental model analysis will be compared with generated data from finite element analysis. With the aid of Monte Carlo simulation and model assurance criterion will determine the accuracy and mode shape representation gained from the frequencies. Expected result. This is the finite element model using CATIA. The total area for one part is 380 mm times 45 mm, where the brown is the upper part, the green is the lower part, and the combination between two parts are shown on the rightest figure. It will only use pet sketch features only. The joining of both parts using coincidence and surface contact. There are four round holes shown in the picture where it is situated by bolts with C-bar on its body and RBE2 on its head. The expected result on numerical analysis or simulation is natural frequency and mode shape. Lastly, project planning. This is the project planning for this semester, which consists of project title selection, literature review, preparation of research proposal, constructing the design using CATIA, proposal writing and prepare slide presentation, and lastly, submission of proposal and slide presentation. For the project planning on the next semester, this is only the projected planning, where the firstly is finite element modeling and analysis, then move to experimental work analysis, which will be assisted by postgraduate student. Then we move to result correlation by using model assurance criterion. Next, thesis writing and preparing slide presentation, and lastly, submission of thesis and slide presentation. That's all from me. Thank you.